Hello, I'm now going to tell you about introduction to computer systems in general. We start by explaining some of the terms. The first one is information technology, which is IT in acronym. So what is it? Well, IT refers to an entire industry that uses computers, networking, software, and other equipment to manage information. So what is ICT? ICT can be seen as an integration of IT with media broadcasting technologies, audio, video processing, and transmission. So ICT is an extended acronym for information technology. So ICT versus IT, what is the difference between them? They're somehow similar. So the term ICT has widely been used in the context of education, while the term IT has been widely used in the industry. So ICT covers any products that will store data or information or programs. Example here is the hard disk drive, which is used in desktop computers. The second example is solid state drive. These are the hard drives that are used in small devices like laptops and so on. So that product, of course, will store information or data or programs. Then ICT covers any product that will retrieve, that will enable you to get back your data. Also, ICT includes any product that will transmit. So ICT has got different areas that it covers. Some of them include education, communication, data processing, and so on. So let us now attack the first part among the two main parts of the computer. It is called the computer hardware. This is the part that puts together all the physical components of a computer that you can see and touch as well. So there are many parts inside the system unit. What do they exactly do? Let us see some of the computer components that make a computer functional. Whether it is a desktop computer or a laptop. So every component in a computer is somehow immediately or indirectly connected to a circuit board which is called motherboard, as you see displayed on the screen. So every computer has a large circuit board which is called motherboard. This contains some of the most parts of a computer, such as the CPU, also known as the processor. The CPU, you see it. You can also call it central processing unit. So the CPU processes information and executes our commands or instructions. So when the CPU is working, it generates heat. That's why it is covered by the heat sink you see displayed, which draws heat away from the processor. It tries to reduce the heat generated by the processor. So the motherboard also contains the computer's RAM, or random access memory. So RAM is the short-term memory that the computer uses when it is performing calculations. However, you cannot store your files or install the programs in RAM because RAM deletes everything in it whenever the computer is shut down. The next component we are talking about, among the ones that are found inside the CPU unit, is the hard drive. So the hard drive provides the long-term storage, keeping all of the computer's data even when it is turned off. So on many desktop computers, the motherboard has got expansion slots. These are expansion slots that allows you to upgrade by adding expansion cards. So you can add a video card to increase the video performance of your computer, or you can add a wireless card to connect your desktop to a wireless network. Most laptops, however, don't have expansion slots because they are very, very small in size. While the computer components need electricity to operate. The power supply unit is designed to take power from the wall socket and send it to all the components that need the power. For laptops, they have a battery that lets you use them anywhere. Of course, the time you can use laptop's battery is limited to its capacity. It can be 1 hour, 2 hours, why not 7 hours, and so on and so forth. So, this is a summary of how few of the internal components of a computer work and some of their functions. Well, the computer has got a power button that you have to press in order to turn it on or off. This is how it looks like for a laptop and also for a desktop. So, the computer also, as we have seen, needs power to operate. So, the cable that is bringing power is connected to the power socket. You see displayed on the screen. So these are different types of power cords that brings the electricity from the wall socket. Some they are used for desktop computers and others for laptop computers. So a computer has got also ports and connectors. Well, a port is where the cable is connected. Let's say on the top image in the left, this is the cable which is coming from a projector or from a screen that uses the VGA technology. So that cable in the right side, now in the left side, will be connected to those holes in the right side on the first row. So the holes which are receiving the pins from the cable, they are called ports. Then the pins from the end of the cable, they are called connectors. So a connector connects to a port. On the second row, it is a cable that uses the technology of DVI. So VGA means Video Graphics Array, and DVI means Digital Video Interface. The next line shows the port of HDMI technology, and on the left side it is the end of a cable that uses HDMI technology. So HDMI means High Definition Multimedia Interface. So a connector connects to a port. This screen also shows other ports, which are found on some of the desktop computers. Of course, some are old. You can't find them on the new computers because they are obsolete. DVI, you can still find it. Serial technology, this one has been used for some printers, some mouse, some keyboard, and so on, but they are becoming obsolete. VGA is also still being used, though on new computers you can't find them. You only find HDMI. So the next port is the one that you connect the network cable. It is called Ethernet port. You can also see the audio ports, where you will be putting different cables to get the audio in or out from your computer. These are the USB ports, where you connect your USB devices, like mouse, like keyboard, like, USB cable that charges your smartphone and so on. The last one is called HDMI that we already discussed. Also, HDMI is used to connect your computer with a projector or a TV screen or any other technology that uses HDMI. So we go to computer software. This is the second main part of the computer software. It is a set of programs that make the computer functional. So there are two types of computer software. There is what we call system software, which is the fundamental part, the very, very important one, which puts together the operating system and the BIOS. Examples of operating systems include Windows 10, Windows 8, and Windows 7. The second part of the computer software is called application software. These are the general software which are created to solve a specific problem. For instance, Excel. Excel is used to perform calculations, to create charts, and so on. Another application software is VLC Player, which enables you to play audio music or video files. Let's now go to number system. So a computer uses the binary number system, which is also called the base 2. It uses zeros and ones. So a computer uses a binary number system which has a base 2, and digits can have only two values, 0 and 1. So, still talking about binary number system, for a computer, everything is a number. Be it a document, be it a photo, be it a video, be it, any file on your computer, any program, it is seen as 0 and 1 for a computer. There is another number system which is called decimal or base 10. It uses digits going from 0 through 9. The next number system is called octo or base 8. It uses 8 digits going from 0 through 7. The next number system is called hexadecimal or base 16. It uses numbers or digits from 0 up to 9. Then from 10 up to 15 it uses letters. A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. So there is a way of converting from one number system to another. Let me show you how first to convert from decimal to binary. Let's say we want to convert 25 from decimal to binary. First of all, we keep dividing the number by 2. The quotient that we get is also divided by 2, and so on until the quotient is equal to 0. So what we are going to do is to record the remainders for each division step. So we start by dividing 25 by 2. So it is 12, and it remains 1. 12 divided by 2, it is 6, and it remains 0. 6 divided by 2, it is 3, and it remains 0. 3 divided 2, it is 1, and it remains 1. Then 1 divided 2, it is 0, and it remains 1. So as the quotient is now 0, we stop the division. Then we record the remainders from the bottom to the top, from the less significant bit to the most significant bit. So we get 11001, which means 25 in decimal is equal to 11001. The next example is to convert from decimal to octal. So we still convert the same number, 25. For octal, we keep dividing by 8. The rest is the same as for binary. So 25 divided 8 is 3, and it remains 1. So 3 divided 8, it is 0, and it remains 3. So as the quotient is now 0, we stop the division and we record the remainders. Again, as you remember, from bottom to top. So we get 31, which means 25 in decimal is equal to 31 in octal. The next example is to convert from decimal to hexadecimal. 25 divided 16 is 1. It remains 9. Then 1 divided 16, it is 0, and it remains 1. We record the remainders, we get 19. So 19 is equivalent to 25 in decimal. The next example is to convert from hexadecimal to decimal. Here the hint is to take the first digit in hexadecimal, you multiply it with base 16 plus the second digit from the left, of course, times 16. Then you power the last base 16 to 0. You continue by powering the next two one from the right to left. Then 1 times 16 to power 1, it is 1 times 16. 16 to power 0, it is 1 times 9. Then it is 16 plus 9, which is equal to 25. This is how we convert from hexa to decimal. The next step is to convert from octal to decimal. So 3 times 8 plus 1 times 8. Then you are going to power 0 to 1. So this gives us 3 times 8 plus 1 times 1. 24 plus 1, which is 25. So 31 from octal is equal to 25 in decimal. The next is to convert from binary to decimal. The steps, they are the same. What changes is only the base. Here we are going to use base 2. So 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. Then we power the base 2 from the right to the left, starting by 0. So to power 0, to power 1, to power 2, to power 3, to power 4. Then this is equal to 2 to power 4 is 16, 2 to power 3 it is 8, 2 to power 2 it is 4, 2 to power 1 it is 2, and 2 to power 0 it is 1. So when we multiply, we get 25. After adding 16 to 8 and it to 1. So this is it. The next conversion requires us to have an understanding of these numbers you see displayed on the screen. So number 0 in hex and in decimal is represented in binary using 0000. So number 1, it is equal to 0001, and so on and so forth. Maybe the technique to help you remember this table is to start from the right side by writing 01, 01, 01, 01, 01. You go to the second column to the left. It is now 00, 2 zeros, 2 ones, 2 zeros, 2 ones, 2 zeros, 2 ones. On the third column from the right, this time it is 4 zeros, 4 ones, 4 zeros, 4 ones. On the fourth column from the right, you write now this time 8 zeros, then 8 ones. Not complicated to remember it by using these combinations. So we are now going to convert from binary to octal immediately without passing through other number systems. So we are going to convert this binary number to octal. So the hint is that 3 bits represent 1 octal digit. So what we have to do is to group 3 bits starting from the most significant bit in the right. So this bit 1, which is at the right side, starting from the right side, is the one having the highest value compared to the one which is provided on the left side. Now, when we group this number from the right side by grouping 3 bits for each group, we see that 101 is equal to 5, referring to the previous table. 110 is equal to 6. 001 is equal to 1. Again, 001 is equal to 1. So this number 1165 is the one which is the value of the binary given in octal. Let's now immediately see how to convert from binary to hexadecimal. Let's say we convert the same number in hexadecimal. Again, the hint is to know that 4 bits represent 1 hexa digit. So group 4 bits starting from the most significant bit in the right. This is it. When we group 4 bits starting from the right side, you can see the zeros, the 2 zeros in red. We have added them, but they don't count. They can't add any value to this number. We only added these 2 zeros in red to complete the set, to make it 4 bits for that group. We again check the equivalent digit 20101, referring to the previous table. So this is 5, this is 7, and this is 2. So the answer is 275 in C in hexadecimal. So how to convert from hexadecimal to binary? You know, it is the reverse operation. So let's say we want to convert this given number from hexa to binary. Again, we remember that 4 bits represent 1 hex digit. So write the 4 bits equivalent to each and every hexa digit. For instance, 3 is equal to 0011, D is equal to 1101, then A is equal to 1010, and 1 is equal to 0001. So the last group is 1 in hex. The second group is called A, that is 10. The next group is D, that is 13. And the first group is called 3. So this is the number which is formed by grouping the binary equivalent for every hex digit. So this is the answer in the binary. The next step is to convert from octal to binary. What you are going to do is to convert 47 from octal to binary. So 3 bits, as you remember, represent 1 octal digit. So write the 3 bits equivalent to each and every octal digit. So the last digit, which is 7, is represented by 111. Then 100 is representing 4. So the answer for 47 from octal to binary is displayed on the screen. Now let's see how we can perform arithmetic operation on binary numbers. The first operation is going to be addition. So we are going to add 1011 to 1110. So before we do any operation, there are some rules which are related to them. For instance, the first rule for addition is that 0 plus 0 is 0, 0 plus 1 it is 1, 1 plus 0 it is 1, 1 plus 1 it is 0, then we carry 1. So 1 plus 0 is 1, 1 plus 1 it is 0, we carry 1, then 1 plus 0 it is 0, it is 1, then 1 plus 1 it is 0, we carry 1. Now we are now to add 3 ones. As you remember the other table, now we have 3 ones. So 3 ones, they are representing 3. So 3 in binary is equal to 1. Then we carry 1 and 0. So it is 0, 1, 1. We write the last one. Then we carry 1 and 0 on the left side. Then we are going to bring down 1. And the 0 is going to be brought down. So this is the sum of the 2 binary numbers. So the second operation is called subtraction. So we are going to subtract 1010 from 1001. So the rules of subtraction, they are displayed there. So 0 negative 0 is 0, 0 minus 1 it is 1. Then we borrow 1 from the left. And 1 minus 0 is 1, 1 minus 1 is 0. So 0 minus 1, as the rule says, we write 1, then we borrow 1 from the left. So this 1 is going to be brought, then 0 is remaining there, then we put the 1 on the right column. So 0 minus 0 is 0, 0 minus 0, 0. 1 minus 1 it is 0. So you can see the difference between 1010 and 1001. The next operation is called multiplication. So we are going to multiply 2 numbers 1011 with 1110. So the rules of multiplications are simple and clear. Rule 1, 0 times 0 is 0, 0 times 1 is 0, 1 times 0, 0, 1 times 1 it is 1. Then we don't carry and we don't borrow. So 1 times 0 it is 0, then 0 times 1 it is 0, and so on and so forth. Then we go to the second one. We're going to multiply it with the above number. So it is 1, 1. Then 0, 1. We go to the third one from the right side on the second row. It is 1, 1, 0, 1. The first one on the second row, multiplying with the number at the top, it is 1, 1, 0, 1. So at this level, we are going to calculate the sum. By calculating the sum, we are going to apply the rules of addition. So we bring down the 0. So 0 plus 1, it is 1. Then there we have 1 plus 1, which is 0, and we carry 1 in the left. Then you have 3 ones. So 3 ones, they are equal to, equal to 3, which is 0, 1, 1. So we write the last one. Then we carry the 1 and the 0 in the left. Then we again have 3 ones. Again, we write 1, we carry 1 and 0. Then 1 plus 1, it is 0. Then we carry 1. So 1 plus 0, it is 1. 1 plus 1, it is 10. 0, 1. like this. So this is the product between 1011 and the 1110. So the answer is displayed as you can see. Now we go to binary division. For the division, you are going to divide this number displayed with triple ones. So we first put 1, then we are going to take 1 and multiply each of the number. So 1 times 1, it is 1 times 1, 1, 1. So when we subtract it from the above, we get 0, 0. Then we bring down the 0 remaining at the top. We are going to divide it with 1, 1, 1. So we put 0, then when we subtract, we still get 0. So this is the quotient between 1, 1, 1, 0 and the triple ones. Before we conclude, let's see very quickly what we call measuring storage capacity. For a computer, everything is considered as a number. Be it photos, numbers, documents, videos, audios, even computer programs, they are all considered as numbers, zeros and ones. So because the computer only understands what we call the binary language, which uses ones and zeros. So the basic unit of a computer is called byte. This is used to measure the capacity of storage devices or memories of a computer. So 1 byte is equal to 8 bits. So they can store 1 alphanumeric character. For instance, if you have letter B and letter S, each letter is represented by 80 bits. Then when the bytes are 1024, they are called a kilobyte. So 1 kilobyte is equal to 1,000 bytes. Then when kilobytes, they are grouped together and they make 1,000, they are called 1 megabyte, as you see. Then when megabytes, they are put together and they make 1,024, they are called 1 gigabyte. So terabyte is equal to 1024 gigabyte. Petabyte is equal to 1024 terabytes, and so on and so forth. You can see exabyte, zettabyte, and yottabyte. Of course, as I said, these units, they are used to measure the storage capacity of different devices which are used with the computers, including RAM memories, whose memories can go from 1 gigabyte up to terabytes. They also measure what we call the hard disk. The hard disk can go for 500 gigabyte and so on and so forth. Then a simple example is to convert 4 gigabyte into bits. So to do it, first of all, let's see what 1 gigabyte is equal to. So 1024 megabytes, they are called 1 gigabyte. Then this one can also be written as 1024 times 1 MB. Nothing changes on this expression. So we know that 1 MB is equal to 1024 KB. So we replace 1 MB with its value. So this is what we get, 1024 times 1024 KB. Then this expression can also be written as 1024 times 1024 times 1 KB. Since 1 KB is equal to 1024 bytes, we are going also to replace it with its value, which becomes 1024 times 1024 times 1024 bytes. Again, we know that 1 byte is equivalent to 8 bits. So when we replace 1 byte with its equivalent bits, we get 1024 times 1024 times 1024 times 8 bits. So by getting the value of 1 GB, now we can get the value of 4 GB by multiplying 4 to the product. You should get 34 billions, 359 millions, 738,000 and 168 bits. This is the product of the entire operation. Thank you. Bye.